So as we deal with larger data sets, it just isn't feasible to do those calculations by hand. Some of the calculations aren't too bad, but especially standard deviation gets pretty painful without a calculator. Also, as we have these larger data sets, it just increases the chances of errors occurring. And with that, we want accuracy when we get our descriptive statistics. So, all to say that we get to rely on technology a bit here. Now, with that, my one little note to say is just make sure you're using the technology correctly. So that's where I'm going to go through the steps nice and slow here so that you know exactly what to do, how to do it correctly, and another piece is just making sure we type in that data correctly. Okay, so I'm going to use the data representing the 15 fictional exam scores from that statistics class. I have them listed out there on our page. And what we are going to do is use a program called Stapplet. So we're going to go to stapplet.com. And when you visit there, see what I'm showing on the left-hand side of our screen here. There's a section on data analysis, probability, concepts, activities. We are pretty much going to stick to data analysis and probability. So for what we want to do with describing numerical data, that'll be in data analysis, and we want to select one quantitative variable, single group. So we're going to go ahead and select one quantitative variable for a single group. And on the page, there'll be some pieces to fill in. So there's variable name, input, and data. Variable name, it just wants a heading for the data. So here we're working with these 15 fictional exam scores. I'm going to go ahead and just put a variable name of exam scores, just to give it some context. For the input, we're going to stick with inputting raw data, so you can keep that as is. And then the data itself, we want to plug in our values. So I'm going to go ahead and type them in. Often what we can do is even copy and paste. In fact, I think I can do that here from the PDF. Let's see if it works while I'm trying to do it. Yeah, perfect. All they have to do is be separated by spaces or commas. I find the spaces are easier to type in. So you'd go 31 space 62 space 65, and you could type them in that way. But most often, if the data is listed, it's pretty nice to copy and paste in. Okay, so now that I have my data in there, let's go ahead and click Begin Analysis. Now, some things we'll see on this page. First thing we'll see is a graph. It's going to automatically display a dot plot. There's this little option here for show box plot. What that will do is show you the box plot at the same time as your other graph as well, just in case you want to see multiple representations at once. So there's our dot plot. We'll use those pretty rarely, but it's a possibility. We also have, I'm going to go ahead to the box plot. That's all ready to go. If you need to graph a box plot, you can go ahead and take a screenshot of that, and that would accurately represent our data. Also, we have a histogram. And with the histogram, sometimes we do want to make adjustments here. So we have options for how to label the histogram, enter the interval width, and enter the boundary value. Of those three options, we'll only ever enter the interval width. This is a spot where we can play around to make the display a little easier to see. So the interval width, that's the same thing as bin width or class width. So with this, I could go ahead and actually it's already, nope, we're going to change that to a 10. And I'm just going to click away from it. So we have these nice bins that are equal to 10, and I can see how many people scored in the 30s, 60s, 70s, 80s, 90s, 100s. And then I can see their frequencies. What's nice about Stapplet is if you hover your mouse over a bar, it'll give you information. So you can see that this bar is going from 80 to 90. And then you can see this little like colon, then 6. That 6 is the frequency. So really all of that information tells me there were 6 exam scores between 80 and 90, where 80 is being included, 90 is not being included. If I go to the next bar to the right, from 90 to 100, there were 3 exam scores. So with that, you can kind of read the graph that way as well to see the different frequencies for each bar that's being graphed there. Okay, so those are some visual representations of our data. For the summary statistics down here, this is often the information we want to collect in terms of the descriptive statistics. So we have N, mean, standard deviation, minimum, Q1, median, Q3, maximum, and then the numerical values down there. If you're not seeing enough decimal places down here, usually the standard deviation will show if you're seeing 4 decimal places or not. If that's not displaying, if you scroll all the way to the bottom of the page, there's this option for adjust color, rounding, and percent proportion preferences. If you click that and go to the second box that says rounding of numbers, setting that to 4 will show you enough decimal places for more accuracy, and also often our assignments in My Open Math want accuracy to 4 decimal places. So make sure you adjust that setting. It should stay the same each time you access it, but if you're not seeing enough decimal places, be sure to check this out as a way to adjust that. Okay, so I'm going to do a quick run through again of what we did here. So going to stapplet.com, you can either enter the website on Canvas. It's available in the quick links, so you can access it there. We're going to go to one quantitative variable for a single group, put in that variable name, copy or type in the data, keeping the input as raw data, begin analysis. You can choose different graphs to display. Typically, we're working with dot plot, histogram, box plot. Histogram, you can change the interval width if you want to change the width of the bars being displayed in the graph. And then the summary statistics gives us lots of information down here. So I'm going to go through what's showing up in those summary statistics, and so that we can just label what we're seeing here. So N is the equivalent of our sample size. So that's the number of data values that we're seeing. The mean is the mean. It's our average, would be another wording for it if we need that value. SD is for our standard deviation. Specifically, this is sample standard deviation. And I'll come back to that in a moment after I go through these as we talk about the difference between sample and population data. And then the minimum, Q1, median, Q3, maximum, all of those together makes our 5-number summary. Okay, so that gives us a lot of the information that we need to work with our data and describe it. Something to note, when we work with Stapplet, it's assuming we have sample data, which is what we will have available to us maybe 95% of the time in our class. We'll be working with sample data. But in this section, there's going to be a few questions that pop up where we deal with population data. So in terms of the mean, what we're getting out here is the sample mean. It is also the population mean. Those are calculated exactly the same both ways. So the mean, we don't need to worry too much about. The standard deviation does have different formulas for sample versus population. So this is specifically a sample standard deviation. So what I want us to think about is, what if we needed the population standard deviation? Sorry, stumbling on my words here. So where this would be little s, this is what if we needed sigma. And for this, what we're going to use is the Desmos Scientific Calculator. So what I'm going to do is take you through with this data, what if, and it's not very likely in this case, 15 exam scores representing a population is not a likely scenario, but just so that we can see the steps with the technology. So again, the Desmo Scientific Calculator is also a quick link in our class, so we'll go there, have it open here. And what we will do is, when you're in the scientific calculator, there's these different, let's call them tabs, I guess. There's main, ABC, and then FUNC for function. Let's go to function. And in the third row, you're going to see mean, standard deviation, STDEV, and then STDEV with a P. That right there is our population standard deviation. So what I'm going to do is select that, and it starts parentheses, so STDEVP, starting parentheses. And I'm going to go ahead and copy in our data. It didn't copy in great, so what I'm going to do is throw in commas to separate it up. Luckily, most of those were 2 digits long. And just separate up this data with a little bit of editing. And close those parentheses. And that right there, the 17.1542, is our population standard deviation. So with that, we can see the numbers are in fact different because it's coming from a different calculation. So in those very few instances where you need a population standard deviation, we're going to go to a different resource, but really this should only come up once or maybe twice in our class. Mostly we'll be using the sample standard deviation, which Stapplet will give us directly right there.